This video will be about logarithmic functions. So, a logarithm is another way of writing an exponential equation. Recall that we usually have something in the form a to the power of b equals c. We can also write this in logarithmic form, where we have log base a of c equals b. So we can look at some examples of this, like 5 squared equals 25. That means we can write it as log base 5, 25 equals 2. So basically, log is the inverse of exponents, meaning that when you take the log of something, it returns the exponent. So here, b is our exponent, and our log returns b. And this is useful because if we had something like 5 to the power of x equals 136, this is something that we can't really easily solve on our own. What we can do is turn this into logarithmic form. So log base 5 of 136 equals x. And so now all we have to do is punch in this into our calculator and we can find x. So I mentioned that the log is the inverse of exponents. Let's look at this in more detail. Let's say we have the expression log base a of b. Essentially here, what we're asking is a to the power of what equals b. And so our expression is supposed to tell us the power. Now what happens if we raise a to this number? Then what we're saying is, first I need to find the power so that when you raise a to it you get b, and then I'm going to raise a to that power. So what I'll end up with is b. So here, if you start out with a log and you take the base and raise it to that number, you end up with the original number that you had, which is b. Conversely, what we can also do is start out with a to the power of b. Now, let's take the log base a of this. So essentially, what we're asking here is a to the power of what equals a to the power of b. So obviously we can see that our answer is just going to be b. We can look at this with an example. So if I have log base 3 of 3 to the power of 1.4, that means what I'm saying is 3 to the power of what equals 3 to the power of 1.4. So we see that our answer would be just 1.4, which is our exponent. And similarly, if we have log 3 of 1.8, and we raise 3 to the power of that, what we're doing is we're asking 3 to what power equals 1.8, and then I'm going to raise 3 to that power, so that I'm going to get 1.8. So we see that no matter what, all of our logs and exponents, they'll cancel each other out so that we end up with just the number that we started with. Here we'll learn how to solve equations that involve logarithms. So these will be things that look like log base a of x equals b, and we're going to be solving for x. So let's say I have something like log base 5 of x equals 3. So the first way I can do this is I can just transform this equation into exponential form so that I have 5 to the third equals x, or x equals 125. The second way I can do this is I can raise 5 to the power of both sides of the equation. So that would look something like 5 to the power of log 5x equals 5 to the power of 3. And so since I know that exponentiation is the inverse of log, I can see that these two will cancel out, and I'll end up with just an x on this side, and 5 to the third, or 125. So either way, we get the same answer.